great warm-up problem for you, or 3 of them actually. Let's go for it. Questions? How did I do last one?
Yeah.
Do you agree with the square root of 40 is the square root of 4 times the square root of 10?
Yeah.
Yes. Do you agree that the square root of 10 divided by the square root of 10 is 1?
Oh, I see that. Okay.
With me?
Yep.
So if I have a square root of 10 on the top and a square root of 10 on the bottom, then those can both cancel each other out. Because I'm multiplying.
Yeah.
If it were one like B here where I was adding, then I couldn't do that.
Okay.
But because I'm multiplying, I can do that. So then that leaves me with 1 over the square root of 4. Square root of 4 is 2, so it's 1/2, which then satisfies my conditions. No perfect square factors inside a radical, no radicals in the denominator, no fractions inside. Other questions? Yes, ma'am.
How do you get 6 square root of 2?
Because 36 times 2 is 72.
Well, what about 9 and 8?
and 8, that's great. But so remember our 3 conditions from Monday? Condition number 1, no perfect squares left inside of the radical. 8's got 4 in it. So you decided to go to Milwaukee, stopped in Fond du Lac and said, "Woo! Hello, Milwaukee!" You know what I mean?
Yeah.
You're on the right path. You just haven't gotten all the way yet. Okay? Everybody else good? All right, let's kick it up a notch. Okay? Today, we're going with different indexes now. Okay? Monday was all about square roots. Now we're going with different indexes. Okay? All right? So now, instead of looking for perfect squares, I have to look for perfect indexes. Okay? Which means that I'm going to have to know my cubics, my fourths, my fifths, all that fun stuff. Okay? So, let's talk about them here for a second. Let's talk cubics. What are the perfect cubics?
9.
9 is not a perfect cubic.
8.
8 is. There's even one before it. 1.
8.
8.
27.
27.
30.
125. There's one in between 127 and 125. 64. 216 is the next one. 343. Sid, you seem to be confused as to how people are coming up with these so quickly.
729.
729 is 2 more. 512 is in between there first. Yeah. How we come up with it?
Multiply 1 by itself.
Cubic. Yeah, cube 1. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. What?
Now you
Then what are you confused about?
No, I was just because Desi kept saying the
Oh,
numbers,
she
but I
kept
didn't
going?
realize
Oh, you
she was
really
using
had to
a calculator.
calculate?
And I was
Oh.
like,
No, I had it memorized.
Oh, okay. I thought you were confused as to why we were coming up with all
no,
these
but
crazy
I was just
numbers.
like, "Jeez, Desi."
Okay? Cubic 4s. Those would be the quartics.
One. 16. 16.
Oh god.
81.
1,296.
Oops, I forgot the 2. I went. And so on and so forth, right? Huh? All right? So now, when I break up 48, I'm not going to break up 48 into 16 and 2, or 16 and 3, excuse me. Because 16 isn't a perfect cubic. Okay? But what? 8 is, though. So I can break this one up now into the cube root of 8 and the cube root of 6. 2 cube roots of 6 would be my final answer here. $80, I'm going to break up into the cube root, the fourth root, because that's what we're dealing with here now, the fourth root of 16 and the fourth root of 5. Fourth root of 16 is? No. 2. Okay. if you didn't see those, you always have this. But now I need 3 of them in my pairing to get one to the outside. So that's where the 2 goes on the outside. And then the other 2, 6 and 2, or excuse me, 3 and 2 are make the 6 still on the inside. 80, same way. Oops. Here now I need 4 of them. To get one out. Yeah. Try those 2.
He's already got that. He's
Multiply
like,
3 this.
7 because they're both outies.
Yeah, right away.
Mhm.
Okay.
So I would on this one. So one option is I can multiply 24 times 16, and then I can work backwards from that. Right? Always an option. Okay? Or I could say that in the cube root of 24, we've got the cube root of 8 and the cube root of 3. In the cube root of 16, we've got the cube root of 8 and the cube root of 2. Cube root of 8 is 2. Cube root of 8 is 2. Both of those are outies, so they get multiplied together to become 4. Cube root of 3 times the cube root of 2, both of those are innies, so those become the cube root of 6. Agree? Okay. This one, I would take first my outies, multiply them together. My innies, multiply them together. So then this becomes 21 times, this is the 4th root of 16 times the 4th root of 5. 4th root of 16 becomes 2. 21 times 2 is 42. Both of those are outies, so they get multiplied together. And the 4th root of 5 is still on the inside. Questions on those 2? Do we like radicals in the denominator? No, we do not. Okay? So, when I'm sitting here and I'm at the cube root of 36, or excuse me, the cube root of 6, right? If I multiply that on Monday, and some people this morning, as they were finishing up the homework that they probably should have done on Monday, today, 2 days later, I'm just saying, back to what I was saying before about putting a little more effort in. Yeah? On Monday, we would multiply this by the cube root of 6 over the cube root of 6. right? What's the problem with that? Right? So radical because I have the cube root of 36 now, right? I'd have to go another one again, right? Or could I just go, instead of the cube root of 6 over the cube root of 6, I could say to myself, well, oops, gotta get back into the marker. 6, if I cube that, is 216, right? 6 times 6 times 6 gives me 216. So, this is 6 times 6 times 6. Well, if I have one of them already, that means I need 2 of them yet. So I'm going to multiply here by the cube root of 36 over the cube root of 36. That gives me 2 cube roots of 36 over 6. Right? Which then 2 goes into 2, 2 goes into 6, so my final answer here is the cube root of 36 all over 3. Because the cube root of 6 times the cube root of 36 is the cube root of 216, which is 6. Okay. You try number 6. Don't get mad at me, Sid. What did I did there?
Since you can multiply 4 by 2 and 8 is
8 is a perfect cube. Yep. Okay. Most of you probably did this. Right? Yeah? Okay. So on top then, we get, or you got, 7 times the cube root of 16 all over 4. Right? But the cube root of 16 is the cube root of 8 times the cube root of 2. The cube root of 8 is 2. 2 goes into 4 twice, leaving me with 7 cube roots of 2 over 2. 7 cube roots of 16 over 4 is a non-reduced fraction. It's like saying 6/8. Okay? Two forms to radicals. There's radical form, which we've been doing, and the other is exponent form. Okay? So you've seen radical form. We've done it the last day and a half of classes. Okay? And now exponent form here would be s to the green box over blue box. The index is the denominator of the exponent. So if I have the 7th root of x to the 5th, that would be in radical form because I see a radical. Correct? Its corresponding exponent form would be x to the 5/7 power. Where we're going with that is we need to rewrite things into the other form. Well, this is 37 to the 1st power. And what's the index on this one? 2. Okay? So this would be 37 to the 1/2 power. Square root is an exponent of 1/2. Fourth root of 27. Do we all agree that this is 27 to the 1/4 power? Where have I seen 27 before today? It's not a cube root. It's a perfect cube. Okay? What's it a cube of? Would you agree with that? And then what do we do with the exponents? Multiply the exponents. So this would become 3 to the 3/4 power. Just when you thought it was safe to go back into math, and bring the alphabet into it. Okay? What makes a variable perfect?
Or whatever the index is.
So what do you mean?
X times x would be x squared, right?
Okay.
The index of 2 that would be q out x.
that what you're trying to say? So a variable is perfect if the exponent on that variable is a multiple of the index. Okay? So, in number 9, what's the index? What's the index? 2. Those. Okay? So my index here is 2. So this would become, if I take just the 8 here, then that would become the square root of 4 times the square root of 2, just like we've been doing for years. Then I take the variable part, and I take each variable individually. Okay? So then this would become the square root of x squared and the square root of x, because I need 3 of them. The 4, the square root of 4, that becomes a 2, and outie. The square root of x squared becomes x, that's an outie. Those two get multiplied together, 2x. 2 and the square root, and x are still innies, so this becomes the square root, or those two combine to be the square root of 2x. So you get 2x times the square root of 2x. You try number 10. I get 2xz times the cube root of 2x squared y squared z.
Let's just say
Mhm.
that you write out all the numbers. So like you write out 2, 2, 2, 2, 3 x's, or
Mhm.
what is it, 5 x's. Can you do that and then cross them out? Will it get
But you'd have to, well, so like what you're saying is, I think this is what you're saying, run down for me. So if I wrote this out as 2 times 2 times 2 times 2 times x times x times x times x times x times y times y times z times z times z times z. Is that what you're saying?
Is it gonna get harder so I can't do that?
No, you can always do that, but your numbers will be bigger, so you might have more numbers out in front. Where you might have 8 x's and 17 y's, and you know what I mean?
Yeah.
You,
Okay.
I mean, it won't get harder than that, but it'll get longer.
Yeah.
You know what I mean? Okay? So, and then there, what you're looking for, then you're looking for groups of 3. So that's an outie, that's an outie, and that's an outie. And then the rest are still ins. Yeah. No, you can always do that, but your numbers will get longer. You know what I mean?
Yeah.
Because if I would have done something here like the cube root of
16x to the 17th power y to the 8th power z to the 12th power.
You know what I mean?
Yeah.
It's just going to be a really long string. Okay. Tonight, your homework is a worksheet. Do